Hello, everybody. Well, Dimitris Mastelos talked me into this conspiracy, and I was excited to change my original title. And rather, I decided to give a personal account of my acquaintance with John and the work we did together. So my new title is Complementing Periodontal Research with John Lambris. Let me first tell you that I never thought I would work in complement. I had a very good reason for that. I studied in the University of Athens. I liked immunology, the way it was taught, except one topic, complement, completely boring, complicated. So when I went to Birmingham, Alabama, UAB, to do my PhD, I didn't know exactly what to do, but I knew one thing: I would not do complement. John Lambris, that all of you know probably, was at UAB, and he asked me to have a rotation in his lab. I was politely found an excuse, never showed up in his lab for any rotations. But in the last semester, last quarter, when we had the immunology, and John Lambris gave a lecture on complement, I said, well, this is not boring, it's exciting, it's very elegant, but it was too late. Anyway, fast forward 16 years later, I am now an associate professor at the University of Louisville, and I was invited by the University of Pennsylvania School of Dental Medicine to give a talk of my work that I was doing at that time, which was about gingivitis, a periodontal pathogen, and its interactions with KIR2, and the topic was whether this interaction was for host defense or immune subversion. That was the model that was suggested by our data. So gingivitis was interacting with KIR2, and it activated inside-out signaling for the activation of Synth11B, Synth18, and beta SMAP1 at that time. It would change its conformation to acquire the high affinity conformation, and then gingivitis through specific ligands will bind this integrin and getting internalized into the macrophages. But the killing was not what you would expect. In fact, gingivitis could survive within the macrophages. Among the audience that day was John Lambris, and after my talk, he came to me and said, yes, nice talk. I would like to invite you for the complement meeting in Porto Kelly later this early next year in June. I said, thank you very much, John, but what do I have to do with complement? And he said, you already studied complement. This is complement receptor 3. Okay, I'm coming. But since I was now into the complement, I gave the same talk with a different title, Exploitation of Complement Receptor 3 by Periodontal Bacteria. Well, since then, we decided to start a collaboration. So John said, don't you want to see what complement is doing in periodontal disease? We have knockouts, we have reagents, ask anything you want at your disposal. So I started doing some literature search, and I found out that in humans there were studies in the 70s and 80s showing that complement activation fragments are more abundant in periodontal disease than in health. But they did not know what complement was about in periodontal disease. It was suspected to play a role in the initial lesion. And there was insufficient evidence to determine the role, if any, that these substances may play at this stage in the pathogen. So if it had any role, it was only in the beginning, the initial lesion. One of the authors that published a lot in the 70s and 80s was Hajishengallis. I saw him in one meeting, and I said, Harvey, you have done a very nice work with complement. Why you stopped researching complement? And he told me that study sections were not interested anymore. In fact, in one time they told him that anything we could learn from complement in periodontal disease is already known. Okay, fine. Nevertheless, we started investigating complement. First, continuing to learn how gingivitis exploits complement, and we showed that gingivitis can exploit C5a receptor 1 to escape killing from macrophages while not affecting the inflammatory responses. So inflammation was there, but gingivitis would survive. We also, with doing more work in gingivitis, we showed that this is a keystone pathogen which exploits complement to promote dysbiosis by supporting the entire microbial community. So gingivitis was incapacitating the killing capacity of not only macrophages but also neutrophils. And this was good for the entire community because bacteria could survive, but also that was a very subtle exploitation. So only the antimicrobial pathways were being incapacitated, not the pro-inflammatory pathways. I'm not going to go into the details now, but this keystone pathogen concept also got into the science popular press, and it was highlighted by Scientific American. Now, I'm not going to go into all the work I have done with John because we published more than 45 joint publications, but I think the essence of what we did can be summarized in this cartoon. Over the years, we have shown that complement is not only involved in the dysbiotic transformation of the periodontal microbiota through the exploitation of complement, but also complement is a key component of the destructive inflammation in periodontal disease that leads to the destruction of the bone that supports the teeth, and the resorption of bone is the hallmark of this oral inflammatory disease. So we decided that, well, because John has always been interested in therapies, which this is the ultimate goal of doing research, we were discussing how we can exploit this knowledge and do something for developing a treatment for periodontal disease. Long story short, we started with mouse models, we went to non-human primate models, and finally we are testing one of his inventions, AME-101, in humans. This is our early work. We showed that mice that genetically lack C3 are resistant to periodontal disease, and this could be verified by different models. This is the oral gavage model, in the ligature model, but also in the naturally occurring periodontal disease, where you don't do anything, you don't intervene, you just keep the mice growing until old age, and the C3 in knockout mice develop much less bone loss than their litter-mate wild-type controls. Of course, like John says, we are mouse doctors, but the point is not to cure mice, is to go to humans. And before going to humans, we decided to go in non-human primates, and using the comstatin analog AME-101, the idea was to block the activation of C3 and thereby the downstream inflammatory pathways that lead to the destruction of the connective tissue, but also the bone that surrounds and supports the teeth. Because if you leave this disease untreated, you may lose the entire tooth, even if it is intact structurally, it will not have any support. We first tested AME-101 in young and non-human primates using the ligature model, treating one side with the drug, the other with a scramble peptide control. Very quickly, we got reduced indices in these mice that indicate inflammation. These are the same clinical indices that are used in humans to characterize periodontal disease. And the most important thing finding was this, that those sites that were treated with comstatin, with AME-101, they got significantly less bone loss. We also tested the same compound in naturally occurring periodontal disease. That was in the Philippines, where they had a large facility and kept mice then in old age, where they developed severe natural periodontitis. And then we were inhibiting periodontal disease clinically, but also by measuring the inflammatory cytokines in the gingival peritular fluid. Even when we gave AME-101 systemically, like when there is indications like PNH and other diseases, the monkeys were still displayed reduced periodontal disease with time, even after the compound, the treatment was discontinued. So it had a long-lasting effect. This picture is taken from last year, and here you can see some of the key people in my lab that contributed to these studies. Here you can see Tomoki Maekama, who also went to the Philippines to initiate these studies and these collaborations. Tetsu Kajigawa, Sao Lee, they were very eager and wanted a picture with John, so they asked me, can we go there where John is and take the picture. In the picture you cannot see Toshikawa Abe because he had already returned to Japan. And this is the guy who developed the ligature model that after he published it, now everybody in the world is using this model and it has speed up developments and knowledge in periodontal disease. This is where we stand right now. This is the trial that we did in collaboration with Hajishengallis, the PI who performed the study in Boston, the Boston Institute, and with Desmond Yambokulu from Amidas Pharmaceuticals, and using two indices of periodontal disease, the gingival index, we showed that the individuals that were treated with ME101 had significantly less inflammation, and bleeding or probing is another readout, and also the bleeding or probing was also significantly reduced by treatment. And please note that these beneficial results were persisted for 90 days after treatment initiation. We have also shown that complement is required for the expansion of the Th17 cells that are the cells that are secreting H17, which is the cytokine that drives bone loss. And this is where we stand now. The next vision is to go for a phase 3 trial and hopefully see a treatment in periodontal disease after so many years, because periodontal disease these days is treated the same way it was treated 50 years ago, simply mechanical debridement to remove the pathogenic biofilm and surgery if necessary. And for this reason, we have open meetings with collaborators. I have mentioned before Alice Hastur, and also George Kotsakis is also a collaborator of ours in our efforts to bring complement therapeutics in periodontal and peri-implant diseases. Now, I don't need to say anything about how great scientist John is. Everybody knows that, and also Dimitri summarized it very nicely. But I would think that another great contribution of John is these AGN conferences. I met most of my best collaborators in these meetings, and the slogan of the AGN conference is bringing science together for promoting exchange of ideas and collaboration. It's not just a slogan of those slogans that we hear every day from politicians, even universities. This is the real thing. This picture was taken 2 years ago, and this is what we do here. We discuss collaborations, Dimitri, John, Brian, and me. Now, working with John and also other people that I met in these conferences, like Kian Kavakis, who is in the audience, I realized that collaborations are synergistic when they combine different talents rather than division of labor. Don't find somebody who is like you if you want to do good collaboration. Find somebody who knows something that you don't know and that you can offer something they don't know. This is the best collaboration. So it is a fashionable slogan this day to say that diversity is our strength. Well, I would add that diversity in ideas and approaches is what makes the real difference. I would like to thank everybody who contributed to these studies. I don't have time to go through every one of them. Also NIH for supporting these studies, both in NBCR and NIAD. The first grant we got with John was from the Dental Institute in 2012. That was not easy because we started from 2009 to get this grant, but we were not successful in the beginning. Like in the 2009 effort, some of the comments you can see here, the proposal requires a tremendous number of animals, trying to do too much in the time available. Lack of certainty whether the results can be reliably extrapolated from the mouse knockouts to the human disease. Well, we have done all of these three concerns, which were not really concerns. So, another thing that I learned from this collaboration is that there are two types of people in this world. Those who find solutions and those who find excuses. And John is this type of person. And I will finish with a quote from one of my favorite actors. If you want to see a miracle, be the miracle. And that's all I have to say. If you have any questions.